Hello, everybody. Thank you for joining me once again. So, an update on my parser generator language syntax. The syntax has changed quite a lot. So, no more car reader, no more token reader. So, this is the syntax in a nutshell. So, you have this structure called a lexer, and a lexer can take grammar instructions. And what it does, a lexer acts on the text and it groups the text into lexons or what's called tokens. So lexons is what it's called. Tokens is when the lexon is saved to a list. We call it the token. So it calls the grammar instructions, parses this, and it parses that, it parses that, it parses that, parse as much as possible. Is this in the token list? No, it's not. Once it parses it, it discards it and moves on to the next. Parse this, parse that, parse this, parse that, parse that. Is it in the token? Heading is in the token, so it saves heading, it discards the rest. It parses this, it parses this, it parses that, parses that, parses that. Key is in the token list and value is in the token list, so it saves both those and discards the rest. And we can define the action, the grammar action, how to do that. The analyzer. So the analyzer now takes a look at tokens. Analyzer don't look at the text. It looks only at the tokens that were generated from the lexer. And once the analyzer looks at the token, or actually looks at the token, it parses these, and these are just the same grammar instructions. And automatically, what you will have is like you'll have a list of tokens generated with only these, and the discard here means that this is included in the token list, but it's not included in the abstracts. It's discarded after we do our analysis. That's what that discards mean. Um, so the generator will automatically generate a list of tokens, and it will automatically generate your abstract syntax tree. However, if you want to edit or dictate how the abstract syntax tree is generated, you can do that. And the way you do that is with the syntax object. So for example, let's say for statement would automatically generate the statement and its key and value children. Well, let's say I only want key to generate. I'll write this. So I say generate statement and generate the key child and all the children of key if key is like non-terminal. I can do the same. I could say something like, okay, generate section, generate all the children in section except statement, right? Um, and I can say, okay, do not generate statement that's here by itself. Like, or if I want to say, okay, do not generate statement that's under section. Another way to do it is would be you go like say, okay, specifically for the section for the statement under section. So this specify the statement that's like standalone, while this specify the statement that's only exists under section. And you say, okay, do not generate, just generate it alone, but don't generate its children. Or you could say something like, okay, don't generate this, but generates its children. Something like that. I probably have to give this more work and more designing to make it make more sense. I probably could attach it here like this. Similarly to how token is attached to Lexer, but the reason why I don't really do this in a way, it's because I could even put tokens here as well. Like, okay, I could say something like, okay, generate identifier or something like this. So in a way, while it's directly related to the analyzer, I feel like there's some things in it that makes it needs to be its own separate thing. And then we can adjust what the tokenizer do from the syntax. Sorry, not the tokenizer, the parser generator. So like I said, by default, it generates a token list and it generates a abstract syntax tree. You can turn those off if you want. There are other things you can set. For example, by default, the parser generator generates a one parser, meaning that the moment you generate a token, it starts to also analyze the token versus it waits for all the tokens to generate and then analyze it. So it's like it's a one parser, right? So we can change it to a two pass parser, right? Or one, let it be a one pass or something like that. And there are many other config which I haven't thought of yet. Also, I probably need to redesign like arrow handling, right? How do I handle an arrow during tokenization? Let's say an unknown character. What do I want to do? Skip the unknown character and continue to parse. Stuff like that I can probably think of putting in the syntax. All right. Okay, so this is just one this syntax example is actually showing how to parse the ini language. All right, so key value and settings. Now this one is showing an example of what we call predicates semantic predicates, and this might be important to make the parser generator um be able to parse languages, complex languages like the C language. For example, one complex feature is the type def, right? So you're taking a user identifier and making it in a type, right? While you can use a regular parser generator and do that, you will have like a more generic thing, and then you will have to do some more analysis of the abstract syntax tree to properly reassign token type, node type to the correct types. But you can help make that work easier if you could just do all of that from the parsing stage. So what we have is like a table table val, tab val. And what this does, this, when you parse something, when you parse some, sorry, when you parse something, you can save the value that was parsed, right? You can save the value that was parsed. By using this arrow symbol. So I take the value that's parsed and store it in this variable. And this variable is a tab val type. And what tab val is, it's basically a stack or a list where it stores all the unique value, or it's a set. We should call it set val then. Set val. It's a set, basically. Let's call it set val instead. So it's a set. So it stores all the unique values in there. So if it doesn't have the value that was parsed by the identifier, it stores it in here. And but it's more than just a set, because set just stores the value. I guess I can keep the tab val name because it's more than just a set. It is also something you can parse with. So after you store it in here, you can use it on parse, and it's like it like let's say I had a language that was like ABC, and I call this grammar action 3 times. That means that A, B, and C is now stored in this. So when I use this in a grammar action, so if I say, okay, parse something is equal to user types, it is equivalent to doing this. A, B, it's equivalent to that, basically. It's like literally writing the text A and then say parse A or B or C. But what you're doing is it's like a dynamic feature for the parser. When you parse something, you store the result in it, and then it parse using the result. You parse the new text using the result that was saved earlier. And that's how you can save that information. So if I parse this as an identifier here, I store it here, it's now custom type. And then I use a lexer and I say, okay, parse this, parse custom type, right? So it's like a custom type here, right? And what I want to do, but yeah, it's a parse it as custom type, which is good, which means it whatever results it get here, like if it parses this my int, it stores it in this tab val, and then type calls tab val, calls the tab val. So when in future parsing and I call type, it checks if it's the built-in type, or it checks the list that the current set that I have saved, and see if any match, and if it match, yes. So that means future this would parse as a type going forward, right? Now in the C language, type def is scoped, meaning that if it falls in a scope, this is to recognize, but it's not to be recognized after that. So what I do is that I create a scoping feature. So what is this is saying is that, okay, this variable that you create is scope. So don't just create, this creates a global variable, right? But what this is now saying is that, okay, don't use the global variable if you come across this. If you come across this, create a new copy, a fresh new copy of this variable and use it until you come across this. Then you use the other variable, right? be like, no, not exactly, but yeah, I would have to fine tune it. I would have to make it work like how scoping works in C, and that would be the default. But then scoping don't work the same way in JavaScript. So if a person is parsing a language like JavaScript, I probably have to do something like, okay, JavaScript style or something, scoping style or something. Or I can create multiple of these. So it's kind of crazy in a way. I will admit, I'm going to admit that this is kind of crazy because the purpose that I'm creating, because I've been trying to create a parser generator for years. I've created one already. Just want to show you that. Okay. Itch.io. What is going on? Okay, itch. And I go to my parser generator, my library. So I created this parser generator, which you can find in itch, right? And in the process of creating this parser generator, I discovered many drawbacks, and I discovered why parser generators are so limited, and why for complex cases it's better that people just use a handwritten parser. So my goal is that I'm trying to overcome as much as that hurdle as possible, right? So that for even complex cases you can still use a parser generator. And I've learned so much, and I believe my current syntax design has overcome a lot, right? The reason why I designed my lecture like this is because the initial way of doing it, where you have, like, for example, you just have the tokens, like a list of tokens or something like this. This way is very limited because this way is like a sieve. And then when you have a case where you have two different tokens, like for example, value that matches exactly, right? Value, identifier, right? Identifier is, let's say, one or more any characters from A to Z. And then you have content, which is the same thing, right? How do you distinguish? The way my parser generator used to work before is that I would assign priorities to these, right? I would say, okay, this have a higher priority of 10, this have a less priority of 5, this have the lowest priority, let's say negative 10. So if I come across, if it saves and all three of these matches, it will pick name, but that is very mundane, still can't work for complex. And I identify the weakness of my parser generator when I try to parse a simple ini language, right? Ini configuration, ini specification. There it is. The ini language is the hardest language. This is the simplest language. It's one of the simplest language that exists, but it's extremely hard to parse with a parser generator. This language, look at this language. It's so simple, but believe it or not, this language is extremely hard to parse with a parser generator. It's extremely easy to parse a language, this language, with handwritten, but it's extremely hard to parse it with a parser generator. Why? Because this part, the value part, can easily match this part. It can easily match this part of a comment. So it's extremely hard. So if you look at my old parser generator, and this is the syntax of my old parser generator. I have like the token phase, the syntax phase, and I have the grammar actions, and then me parsing each of these, right? This is a syntax. And let me show you the language that I use for this. My solution for this in my old parser generator, right? So my solution for this in my old parser generator was this, right? So, okay, so I'm trying to parse, right? So I only implemented basic features. Okay. So okay, I have alpha, numeral, other, name, comment. I look at my comment. It's either this character or this character followed by one or more um characters that is not a new line, and then followed by a new line, right? Then of course space, and value. Now, when I was trying to write this ini language in my parser generator for the first time, I didn't have this feature. And then I realized I couldn't parse it because when I was trying to define value, it will overlap with comment, it will overlap with name. And therefore I realized I couldn't parse it. So I literally invented this just to parse ini, right? My parser language could have parsed JSON extremely easy because I trained it on parsing JSON. It could have parsed JSON very easily, but you just couldn't parse ini, and ini is more simpler than JSON. So I call ini the simplest language that's hardest to parse with a parser generator. So what I'm doing, I'm creating a new version of my parser generator, and I've wrote it at the bottom here. I think I've already, yeah. So I'm creating a new version of my parser generator, and I'm really building it from scratch. So here I'm using a command called previous, and what this means is that check if the previous token that was parsed was an equal sign. That's all it does. And it worked, but when I tried to parse even other complex language, it doesn't work so well. I had a lot of problems, right? So this new version of my parser generator that I'm creating, it's trying to overcome all these problems and make my parser generator able to parse complex languages. And I don't have any problem parsing ini here, because this is how I parse ini. I use this Lexa action grammar. So even though this, if you look here, it overlaps with comment, right? Even though, and it probably overlaps with, identify, because if you're parsing, I think I missed something here. Should have one or more right here. Because if you're parsing a series of characters, as long as they're not new line, semicolon, or end of file, it will match this as well. But what's so special is that I put it in this form where I say, okay, match an identifier first, match a space if there is any, match a equal sign, match a space if there is any, and then match value. And guess what this is? This match exactly how handwritten parser does it. Because in a handwritten parser, you will call something, you call a function, like you will say, okay, you will do something like, okay, parse identifier. Followed, let's say I'm parsing in C, right? Followed by skip space. Followed by parse the equal sign. Followed by skip space. Followed by parse value. This is how handwritten parser does it. They just call the functions where they need to call it, and that's what makes handwritten parser able to parse so many complex languages easily compared to parser generator. And what my parser generator, it mimics that by in your lexer, you're mimicking like parsing sequence. So even though this can match comment, I'm only checking for this after all this sequence. So I know this must be a value, even though it could match anything. And so what I'm doing, I'm creating a parser generator to overcome the hurdles of parser generator, to by incorporating various features from handwritten style, how a handwritten person writing a parser by hand, I'm incorporating those things in my parser generator. So why do I want my parser generator to be almost as good of, if not as good of, if not better than a handwritten parser generator? Because let me show you something. Let me go to GitHub and look at a ini parser, right? Let's look at a ini parser in GitHub, right? And we're going to look at an ini parser. No, this is just a random ini parser in GitHub, right? First one I found. Look at this, right? How many lines of code? Almost 1,000 lines of code, right? And you have code for errors for a lot of things. But what I want to look at is just the code for parsing the actual syntax. That's what I want to see. Okay. Thing. Let's parse quoted value. Here it is. I think this is it. Yes, this is it. I think. Yeah. So look at this, right? It's a lot of, well, that's may not be only it. Let's see. This is it. Right. So here's the code, right? So it's in a while loop, right? That's fine. Basic coding. And he has all these things. Okay, line empty, line comment, blah, blah, blah. And yeah, and some other stuff. Anyways, you get the drift, right? And this might not be not be that complex because it's ini. Ini is a very simple language to parse, but it's 1,000 code. There's a lot of little things being done, like a variable being incremented, another variable being incremented. You're assigning a variable with a thing. So let's say you are making a software, right? You're making some software and your team decided, or if it's you're working solo, you decided that, okay, we're going to create a configuration file for a software that our end user can edit the configuration file, or we who maintain the software can edit the configurations file to do that. And you say, okay, we're going to base it on ini for whatever reason. It could be that you say, okay, ini match exactly what we're trying to do in the configuration file. So we're going to base our configuration file on ini. Okay, so you take the syntax of ini as your base for you're creating your own configuration language. And you say, okay, we're going to add some features. We're going to, let's say, you're going to say, okay, you're going to add some keywords here, right? And you're going to add some special number code here that the user can put in. And then you say, okay, values are not going to just be text, right? Values can be of a specific type. All right. And then you say, okay, if it's like this, it's a text. And then you say, okay, if it has some special code here, then it's of like a special type. What happens now is that you have to go back in the handwritten parser and figure out how to implement all these changes to make this parser parse your new language, right? And that is tedious because, first of all, I have to go through all of this and figure out how it's working. And then I have to make code changes, add code, and I have to test. And more than likely, I'm going to introduce a lot of bugs. I'm going to test, I'm going to break stuff, and it's going to be a tedious process. So that is why I want to make a parser generator as good as handwritten parser, so that I don't really have to do all of that. I could just come here to my simple parser generator, which is just less than 60 lines of code. More than likely, I want to be changing these, so I want to have these. I want to be changing this either. So ideally, it's just 35 lines of code, and I'm seeing what I'm parsing, lexing right here. Actually, less than 35. Remove that. It's 27 lines of code, right? I'm seeing what I'm lexing here. I'm seeing what I'm analyzing. Okay, I know I added some new features. Okay, so I need to tweak this, right? Key heading right here. I need to tweak this. Now this accepts some code. So simply I just put this. It can have 0 or 1 occurrence. Add in some kind of code. I don't know, this, that, and some code. Boom, I'm done, right? Easy to edit. This is why I prefer parser generators than writing parsers by hand, but I do want to make a parser generator that is extremely resilient. I do want to do that, right? So what I show here is, so this technique make the parser generator operates like a handwritten parser, which eliminates a lot of problems that parser generators have. So the other thing, right, that I that this was actually advised to me by persons on Reddit, because I shared my initial syntax on Reddit, and someone mentioned that, hey, language have what you call syntactic semantic predicates, and I notice your syntax don't have it, your syntax will do well with it. And I look it up and I realize it's actually an extremely useful thing, right? It's called semantic, but this one is called syntactic, right? Let's see. I don't think this is what I'm looking for. Anyways, when I researched it and asked AI, it's semantic predicates. I don't know why it's a semantic. Isn't there something called semantic predicate? Yes, it is. And yes, it was in Antler Tree, but it was removed. Yes, this is exactly how it's done. Like, for example, now the example that I got, right? It's something with Antler, right? And it's something like this, right? Um, when I checked AI at the time, any new file, yeah. When I checked AI at the time, it was like the way Antler does it is like I would have something like identifier here, and then I have a function and say, okay, is type, right? Meaning like, did I parse something like a type def here and say, okay, int, and then I say, okay, name. Say name is now an identifier. So what I will do, I'll set something like add type, right? And then I add name, which is right here. So so this is what I'm designing here in the parser generator with these user tables. So if I parse something, I save it here in the tab val, and then I can parse with the tab val, right? And then because type now Um, and this uses the lexer, right? Because this is not going to just put any identifier. It is right here. So let me move that. It's right here. Custom type. So this is custom type is only parse after type def, which means it's a type, right? So I'm creating this parser generator. I'm going to be um releasing it soon. So I hope you guys would be interested in giving it a try. I started out building it as a tool that I want to use because my goal is to create my own programming language. And as a programmer, I always end up needing some parser at some time. So, and I don't like writing parsers by hand. I rather have a parser generator. So I'm just creating a parser generator for my needs, but I'm trying to make it as good as much as possible where I can share it with the public. And I hope that you could understand, give it a try, right? Another thing though is that C has what's called scopes, and then I realized I'm going to have to implement that because if I didn't have, for example, any scope, what happens is that the values that I'm storing will work in places where it shouldn't work in the language, and I'm trying to do it as much as possible. So in one of my first um in one of my first iteration of the syntax, because I have been designing a lot of things. So see so much that my syntax has changed. Let me see here. Okay, so in one of my first iteration of syntax, I thought of creating something like this called a processor. And what a processor does is that it allows me to create custom using a domain specific language to have more control to create stuff, right? And the reason why I did this was for Python, because I wanted my language to be able to parse Python. Python has something that's extremely hard to parse. And the one of the main reason I'm creating a new parser generator is because my old parser generator could not parse Python. Could not parse Python directly using the language. Um, Python is a indentation language, right? And where it is. Yeah, I'll find it here. I do have a link to it. Here it is. Right. Let's go to indent. There it is, indent. So this is how Python generates its indent and detent tokens, which you cannot do with a parser generator. You have to do it handwritten. And that is why I was thinking of creating this thing where I create like a processor to do this stuff. And then I gave it some more thoughts, some more thought process, right? And I realized that this is going to be extremely hard to implement, and I don't got time to that. I'm not trying to spend 5 years working on a parser generator. No way, because I don't think I'm going to make that much money from a parser generator anyways. And my goal is for it is to not make money. My goal for it is to be a building block that I can use and build other software, right? I'm not like, I don't got time for six. I know there are developers that sit down and spend 1 year, 2 year, 3 year creating something. I'm not one of those developer. I prioritize speed, and I want to do this done. I want to get this done as quickly as possible. So basically, I said there's no way I'm going to do that. So I thought of another way. What if I create like a plugin system, and then the users can import like some indentation logic for Python and then use that? And I said, that's also hard to implement, to go and implement a plugin system. I mean, why I'm going to force myself to invent a plugin system, and I don't even know if people are going to like my language. I don't even know if people are going to want to use my parser generator on a massive scale where I need to do that. So I say, okay, I'm going to focus on creating my parser generator and implementing core features built in. And I looked at it and I said, okay, and I did some research and I said, okay, indentation sensitive languages, right? And I realized that they're almost all pretty much the same, right? Uh, and I realized I probably could use the Python indentation technique to parse all of these, right? So I said I should just build it in. So I should just build in the logic, and I can say something like this, like indent equal indentation indent. And basically, this is a built-in feature that generates Python indentation logic. And if you want to use something else, you can probably tweak, say, okay, YAML or something. Because I think like most languages use the same technique, right? Most languages that use scope use a similar C scoping technique. That's why I think it's probably okay if I have something like this, because most languages use C style scoping anyways, right? And if a language doesn't use C style scoping and I want to support that, I can build it in eventually in the future, right? Most language are going to probably use Python indentation style. And if a language use some indentation style, sorry, for indentation sensitive language, that is, if a language use some indentation style that is not supported, yeah. Is I did some research and I know that Python uses a parser generator peg for the syntax analysis part. It uses a handwritten parser for the Lexer part. And the reason why I couldn't do that approach is because the indentation part, it's very codey. Like you have to do some if then else, generate indent token. You have to pop things off the stack. So because I don't want to implement a domain specific language, I say, okay, I'll just implement an indentation feature strictly for Python that can be used in the parser generator directly. And for me, I think that's a good idea. So yeah, I could do that. Yes, I don't know if I have one here where I was testing a more up-to-date one where I was testing my syntax on Python. Let me try this one, parser 4. This I was considering something like peg parser, where you do the Lexa handwritten. But for now, I'm going to avoid that. I'm just going to create a nice simple parser generator that can do some core things. And if it gets popular and a lot of people make demands for features, then I will consider adding additional features. But if not, it will be core enough for the work that I gotta do personally, because that's what I wanted for. I wanted to make do my thing. So if you guys like what I'm doing, consider subscribing to my channel to follow me. Um, this is just one step in the path, in the journey that I'm going. I'm looking for, okay, let's see. This is my personal notions. I don't want to accidentally show something that I don't want to show. Oh, I think this is what I'm looking for. Yes. Okay, so why am I doing this? I'm creating a parser generator, right? I'm building it from scratch. I have one that I made already, but I just don't think it's good enough. And I'm going to build it. I'm going to, by the way, if you spend $20 on this and buy my old version, you will get the new version, because I'm going to replace the old version with the new version in the same product, right? And you will get the source code, full source code for the old version, right? Um, and right now I have binaries for only Linux, for Ubuntu, I should say, and Windows, but you will get the source code that you can compile it on Mac if you want, right? But why am I doing this? I'm building a parser generator, right? And after I build my parser generator, guys, I'm going to be building my hen programming language. I do have a suggested syntax, right? You can check it out. So the hen programming language, I created this syntax, and this was the old name I was going with, the Algodal Zen programming language, but I'm no longer going with that name. The name is hen, right? And I even have my GitHub up, right? I even have my GitHub up. My goodness. Anyways, I'll show you later. So yeah, so my syntax is kind of similar, because this was a syntax I started out creating, and it's changed a lot, but it's still similar to this. So if you want to have an idea what my syntax is going to look like, you can take a look at this. This is public, it's my gist, right? So I'm working on the designing a programming language, right? And go to GitHub. Let me go to Henlang. I wanted the name Hen, but someone already took it. But yeah, you can search Henlang, and that's where I'll be posting for the programming language. But for now, I'm working on the text parser generator. I'm going to aim to complete it in less than 6 months. Then I'll start working on my my programming language. It's a system programming language that is going to be an alternate alternative to C, and it will have safety features for memory safe programming. And I will create my own build system to replace CMake. I don't really have anything against CMake, but it's just that I love CMake. Actually, I use it for all my projects, but it's that I just feel like CMake can be more versatile. Like when I used to program in Java and I used to program using the library libgdx, I used the Gradle system. That's what libgdx comes with, the Gradle system. And from then, I always admired the way the Gradle system worked. And before the Gradle system, I used Marvin a little bit, and I've always admired how those work. And the hen build system will be like a fusion between them. This will be like a fusion between CMake, and Gradle. So I'm going to take the best of both worlds and create a very flexible build system. CMake is not really a build system. It's more of a build generator because it actually generates other build system, right? But for me, that's not the approach I'm going to take. Or I could take that approach, who knows? But really and truly, it's going to just be a build system like Gradle, like straight up build. um I think it's going to be challenging because like the only challenging part I'm thinking of is like, how do I make sure it's cross platform, and or do I make sure that when I build stuff I build it cross platform? But it's going to be a learning experience. It is going to be a learning experience, and it's a learning experience because I did my research, I reached out to the Reddit community, and I learned a lot. A lot of people responded to my posts, and that's how I learned a lot. I never thought of the syntactic predicates before, and learning these things before I actually like start programming the parser generator has been great, because I would have designed a poor language and start programming for a poor language and then trying to fix it at the end, which wouldn't have been so great. I actually have a few more comments. Okay, yeah. Yeah. So yeah, here's the here's the post I make. If you are interested in going on Reddit, building a parser generator, yep. And I got a ton of feedback, guys. I appreciate this feedback a lot. This guy was suggesting that I use this, but I want a bracket for something else, so I use the angle brackets for these. Yeah. So if you want to comment on Reddit, there it is. So yep, my goal is to create this parser generator, then create my programming language. What type of programming language is going to be? Think of Zig, Odin, Rust, C3, those new type of programming language whose goal is like to be like a better C or a replacement to C, etc., etc., a safer C, etc., etc. That's what Hen is, right? I'm going to compete in that sphere as well. Also, in the same subreddit, there's a lot of people posting some really nice um programming language that they have created. So I guess Zig, Zig, C3, Rust, and Odin are the popular ones, but a lot of people out there are making languages, and I looked on a few of them, and it's pretty interesting, you know. So you can, this is a very interesting subreddit if you're interested in compilers and stuff like that. Well, ultimately, my goal is to make video games, and I don't think I'm going to try to make any software anytime soon where I'm going to like try to make commercial, because I made my parser generator in a commercial product. I don't think I'm going to make any commercial software tools anymore for a very long time. If I create an internal tool for myself and I find it useful, I'm probably going to just release it for free, maybe even share the source code. But I find designing and building a commercial software product is very difficult, because you have to reach out to the public and get feedback, because you got to try to build a good product, right? It was very difficult. And I don't think I can manage doing that anytime soon, right? So this is what this part for other application. My primary goal is to make video games. I want to focus on making video games, right? But what I'm doing right now is I'm creating the building blocks that I'm going to do it. Like, I tried building my game in C. I love C. C is my main programming language. I think I deleted it, right? I have it on GitHub, right? And I don't know. It's like in the past I would code in C and it's fine, and I'll develop what I'm developing in C, and it will be fine. But lately I've been finding like maybe it's because I'm exposed to newer languages and I've been trying newer languages. Lately, I've been finding that I just don't find any more pleasure coding in C. I don't know how to explain it. Because I was developing a trading card game. I even posted about it. And then after some time, I just decided like, I just don't enjoy the game, enjoy writing the code in C anymore. Right? I was writing the code in C. I think, yeah, I was writing the code in C. Is this Raylib or I think I was giving Raylib a try because I'm normally a STL guy. So I was giving Raylib a try and I started putting the cards on the screen, right? And it's like a part of me was like, you know, I'm sick and tired of writing these includes. I'm sick and tired of structs. I can't inherit from structs. I'm sick and tired of writing some of the basic things manually. I wish the language was advanced enough. It just provide me a lot more convenient features. And that's why I just say, you know what? I can't enjoy writing the code of the product that I want to create. I need to create a new language. So I considered going to Zig, Odin. I consider when going to Zig and Odin, right? I looked at C3 and I looked at Rust, right? Right. I did look at I never meant for this video to be so long. But anyways, I looked at Zig and Zig was the one that I came closest to use because I really like Zig. I was following Andrew Kelly before he got popular, before Zig got popular. I remember when he was posting on YouTube and he was posting he was building the language for the first time. But I think before he even came up with a name for it. Because at that time I was researching parsers and I was looking to create a parser generator. And yeah, I like the language, but the problem is I don't like how they change it, the syntax style to the syntax style it is. I prefer C style, variable then name, rather than name then variable. And I even looked at Jide as well. So, and Odin. So the reason why I'm not choosing these guys is because I don't really like their syntax style, right? I like the concept, I like the language, I like the defer feature, I like a lot of things, but I just like, I don't really want to code in that style, right? They changed a lot of things and they invented a lot of things, and it's not everything I like. And it's like, I get to the point where I feel like I just want to write code in something exactly for me. And with LLVM as it is, people are creating languages every day. As I show here, almost every day someone is showing a language they invent. LLVM has made creating a language so much, and some people might have bad things to say, like even Zig say they want to move from LLVM. I mean, that's them. I think LLVM has made creating my own language a simple task. All I need to do is to create the parser. That's the hard part, creating the parser, which is going to be made easy by my parser generator, which is what I'm building right now. So I'm going to just create a language for me. I mean, if other people like it, I've already mentally put it in my mind that if nobody cares about my language, no one use it but me, that's fine. I'm creating a language just for me. I want a language where I can sit and write my code, my low level code, write my video game, run my video game. That's what I want to do, right? And it's going to be fully compatible with C because I'm not in the business of trying to replace C. I'm in the business of creating a language that I can enjoy to write in. So if all the libraries I use are in C, that's perfectly fine. My language is going to work with them out of the box, right? So LLVM C3 was kind of nice, right? C3 was kind of nice, but the problem with the C3 programming language, it's just that I don't like I don't like some design decisions. Like, for example, I don't like being forced to write the namespace. Like, it defeats the purpose, because one of the features that C lacks is namespacing. You have one global namespace and that's it. If I'm forced to write the namespace, it defeats the purpose. Like, they need something like C++ where you have namespace and you can skip writing the namespace predicate. Like, some design features of C3 I don't like. So that's why I'm not going with C3. But I think I like it, and I do wish it success, because I think we need something like this. We need something that, hey, I am a more modern version of C, right? Same base root, but more modern. Not trying to be backward compatible like C++, which you end up creating this Frankenstein craziness, but you have a nice, sleekly designed language. And yeah, I think it's a great language. I just don't want to use it. I just want to use my own thing. Rust, I looked at Rust. There's an interesting YouTube channel that I liked a lot where it talks about Rust designs and explain why Rust is Rust. There's controversy with Rust, and there's some reason things I don't like about the Rust community, the way they behave, and I don't like the way Rust is inorganically just inserting itself in everything and trying to take over the whole low level programming world, and just want to be the only language in existence. Like, some things about the community I don't like, but looking at the language itself, I think it's a good approach, right? The whole safety feature, ownership monitoring. I think it's one approach, but I don't think it's the only approach, and I don't necessarily think it's the best approach. I think it's a bit counterintuitive, because now, as a programmer, I have like another level of thing I have to think about. This whole borrow ownership thing, and I think that the language makes me work for it, and at the same time, you still end up with a lot of problems. So in the end, it's not for me, not language for me. Um, so that's why I'm going to create my own programming language. I'm going to create my own build system. CMake is the whole feel of CMake is old. I think a new build system is needed. And I think a lot of people create their own build system. Zig built its own build system. I think C3 has its own build system. Rust has its own build system. I think Odin has its own build system. So most languages create their own build system for their language. But me, I'm creating a build system not only for my language, but a build system that can be general purpose and used for other languages, used for other systems as well. But my primary focus is to make games. I want to be an indie dev. And when I start making games, I hope you guys follow me and support me. And I hope you guys support me along the way for all the steps of the journey. All right. Thank you. Have a blessed day.